Alright, so today we're talking about direct variation. Below there is a table that shows the mass of a gold bar with volume in cubic centimeters. So if we look, our first column is talking about the V, so this is our independent variable, so that would be considered like our X. And then the mass is the dependent variable, so that's what depends on the mass, depends on the volume. So that would be our Y. Alright, so the first question asks, does this table represent a function? So in order to look at that, we need to see, does our V values, do they repeat? So we look, none of those are repeated, so that is a yes. And the next thing is, can we write an equation to this, to represent this data? So in order to do that, we need to see what that change is. So the change between 0 and 19.3 is 19.3. Between 19.3 and 38.6 is also 19.3. And since these all go up by 1, then it has a constant rate of change. So this is a function where we can put it in terms of m and v. So m equals, with our change, 19.3 v. So if you want, you could check it, plug back in your v's, and see does that match our table. And it does. So if I look at this and I double the volume, so I'm going from 1 to 2 and I double it, the mass also doubles. Okay, if I triple it, so from 1 to 3, the mass also triples. So because this is the case, you can say that the mass varies directly as the volume. Okay, they're a direct component of one another. So with this is an example of direct variation. So as one thing changes, the other changes at the same rate. So the next part is the definition. A direct variation is a function described by an equation of the form y equals kx. So that's the key thing, that's what we're going to be using throughout this whole lesson. K is a non-zero, so it means it can't be zero, constant. So constant just means it's going to be a number that changes at the same rate. Alright, it can be said as y varies directly as x, or just there's other different ways it could say it also. You also need to know that k, that number in front of x, is called the constant of variation. So this is important because any time that it asks for that, then you need to know that you're looking for this k value. Alright, some important things to note is that a direct variation always contains the point 0, 0, so it means that whenever you're graphing it always starts at the origin, and that constant of variation k can also be thought as the slope, so the change in the y divided by the change in the x. So k equals y divided by x. Okay, so whenever you're trying to figure out if this represents a direct variation thing, you can just take your y1 divided by x1, and if it's equal to your y2 divided by x2, then you know that it's a direct variation problem. Alright, so if we go down to example 1, we are given the problem, given that m varies directly as n, and that m is 42 and n is 2, I want to find the constant of variation. So that means I want to know what k is. So if we use the letters that they give us, so m varies directly as n, so instead of x and y I have m and n, this is the formula we're going to be using. So I'm just going to take the numbers they give me, 42 and n, or 42 and 2, and plug them back in. So 42 equals k times 2. Well, to solve for k, because this means multiply, I'm going to divide by 2, and I know that k is 21. Okay. Had this been, like in your homework, the first couple of problems ask you to find the constant of variation and then the equation, you just want to take this and plug it back in here. So that would be m equals 21n, and that's going to be the equation for it. Okay. So I'm going to be using this in the next one. So I want to find the value of m when n is 3. So I'm going to use that same equation that we just wrote. And I want to know what m is when I plug in 3 for n. So m equals 21 times 3. And when we do that, we get that m is 63. Alright, this word problem has to do with interest earned and savings. So if we look, that the amount of interest earned is directly proportional to the amount of money saved. So $104 is the interest earned on $1,300. So when we write that equation, 1,300 equals 104K, or I could put K in the front, it doesn't matter, the order means the same thing. And then I want to find out what that K is so I can figure out the answer to the second part. So if I divide by 104, I have K equals 12.5. So that's going to be my interest rate. So if we go and we look at the second question, it wants to know how much interest will be earned on $1,800. So my equation would be y equals 12.5x if I'm using those numbers. So if I plug in 1,800, that would go into the y value. So 1,800 equals 12.5x. So then to solve for that x, you need to divide by 12.5. So x equals 144. So that's how much interest they earned if they invested $1,800. Alright, I'm going to go ahead and flip this over. And example 3 just asks for the constant of variation, but I'm going to put and write the equation so that you'll get used to that, because that's what the homework asks. So make sure you read those directions specifically so you can make sure you're doing what it's asking. Alright, number 1, y varies directly as x, and y equals 18 when x equals 6. So again, I'm always going to start off with that equation, y equals kx. Okay, then you plug in the information you're given. So 18 equals k times 6. Well, solve for k, we'll divide by 6. So k equals 3. So there's your constant of variation. That's the first part of the question. Then the equation would be just take that 3 and plug it back into the top. So y equals 3x. That's your equation. Okay, so you would do the same thing on number 2. The only difference is it's dealing with fractions. And same on number 3. This one is written a little bit differently. It just says it's directly proportional, but it means that same thing. So S equals KP. So whatever letters they give you, those are the letters you're going to use. So I have 256 equals K times 16. Figure out what K is, divide by 16. So K also equals 16. So there's your constant of variation. And then if I wanted the equation, I would just have S equals 16P. So both of those would be the answer. If we look at example 4, they give us ordered pairs, and then it wants us to find the missing value. So if you remember from the front, it gave us the definition, and it said that you can think of K as being the slope. So the change in y over the change in x. And then it said you can use proportions to help this. So if I look at the first one, and I do my y divided by my x, it needs to be equal as the second y, which we don't know, divided by the second x. So those need to equal the same thing. So from here I can just do cross multiplication. So 6y2 equals 15. Well, to figure out what y2 is, divide by 6. When I reduce this, I get 5/2. So there's your second y. Okay, and you can do that same process for this one over here. Example 5 wants us to state whether or not each equation defines a direct variation. So this is where you need to think of what does that mean. So it needs to be in that form, y equals kx. So if we look, your constant of variation is always being multiplied by x, so it can't have any other operations being done to it, so it has to be k times x. And then there's also no y-intercept. So if there's a plus something out here or a minus something out here, then it's not direct variation. So let's go ahead and we're going to look at all three of these. The first one, your whole goal is to get the y by itself so you can determine whether or not it's direct. So I'm going to divide by 4. So what this gives me is y equals 3/4 x. Well, if I look, that's 3/4 is being multiplied by the x. So your k would be the 3/4. So that is a direct variation. Okay. If we look at the next one, to get the y by itself, I would have to divide by x. So I have y equals 6 divided by x. Well, as I said before, it has to be something times x, and now I'm doing something divided by x. So this is not direct variation. Okay, the last one, if I'm trying to get y by itself, I'm going to subtract 2x. So I have negative 3y equals negative 2x plus 6. Well, already, because of this plus 6 out here, we don't have anything plus out here, so this is also a no. So that's how you need to think about it. It has to be of this form. Alright, last examples. State whether or not the given ordered pairs are in the same direct variation. So we need to see, do they vary at the same rate? So in order to do this, you're going to take all of your y's divided by your x's, and they have to be the same. So think of your slope. So 4 divided by 2 needs to equal 12 divided by 6 needs to equal 10 divided by 20. So I look, well, that's 2. That's also 2. Oh wait, this was wrong, sorry. 10 divided by 20 divided by 10. That's also 2. So that are all true. So this is direct variation. So we look at the next one. 1 divided by 1 needs to equal 1 divided by 2. Well, right there you can see that those are not equal, so this is not direct variation. So that's what you need to do. You need to go through, and if it's in a table, just do the same thing. It's the same thing as the ordered pairs. So that would be the same as if I had it written like this. I would need to take those divide, those divide, those divide, and see, are they equal? And if they're not, then you need to write no, because it's not direct variation. So I hope that was helpful. Here is your assignment, A11, page 76, 2 through 26, even. If you have any questions, please let me know, and good luck.